Do you want to successfully complete the D320 Objective Assessment exam? Then you're in the right place. Our website provides a list of questions and answers for your success in the D320 OA exam for free. We understand that acing your OA exam can be quite challenging. That's why we provide completely free exam guides and practice questions for you. In this video, we will cover questions from cloud service models, cloud deployment models, shared responsibility model, essential cloud characteristics, and cloud storage types. So let's get started. 1. Your retail company experiences 90% of annual traffic during Black Friday week, but maintains infrastructure year-round. Which cloud characteristic would most effectively address this resource waste scenario? A. Broad network access. B. Rapid elasticity. C. Resource pooling. D. Measured service. Can you guess the answer? Correct answer, B. Rapid elasticity. Explanation: option B is correct because rapid elasticity allows infrastructure to scale up during peak demand and scale down when not needed, eliminating waste. Option A is incorrect because broad network access refers to the ability to access the cloud services from a wide range of devices and locations and does not directly address resource waste from seasonal traffic patterns. Option C is incorrect because resource pooling allows multiple customers to share the same physical infrastructure, but doesn't automatically adjust resources based on traffic demands of a single customer. Option D is incorrect because measured service provides detailed tracking and reporting of resource usage, but does not automatically scale resources up or down based on demand. Let's explore why rapid elasticity is the game-changing solution for seasonal businesses. Imagine you're running a retail company that sees 90% of its annual traffic during Black Friday week. That's like having a massive stadium full of customers for just 1 week, then near empty stores for the rest of the year. Traditional IT infrastructure would force you to maintain expensive servers and systems capable of handling that peak traffic all year long, even when they're sitting mostly idle. Rapid elasticity is the cloud characteristic that acts like a rubber band for your infrastructure. It automatically stretches to accommodate massive demand during Black Friday, then snaps back to a smaller size when the rush is over. This means you only pay for what you actually use, eliminating the waste of maintaining peak capacity year-round. While other options like broad network access give you connectivity, resource pooling shares resources efficiently, and measured service tracks your usage, only rapid elasticity directly addresses the resource waste problem by dynamically adjusting your infrastructure size based on real-time demand. 2. A financial institution requires complete control over their trading algorithm's customized Linux kernel. Which cloud service model best accommodates this specific technical requirement while leveraging cloud benefits? A. Software as service. B. Platform as service. C. Infrastructure as service. D. Function as service. Do you know the answer? Correct answer, C. Infrastructure as service. Explanation: option C is correct because infrastructure as a service provides full control over the operating system, allowing custom kernel modifications while utilizing cloud infrastructure. Option A is incorrect because software as a service provides ready-to-use applications with no control over the underlying operating system or infrastructure components. Option B is incorrect because platform as a service manages the operating system for you, preventing custom kernel modifications or specialized operating system configurations. Option D is incorrect because function as a service executes code snippets without providing any control over the underlying operating system. To really understand why infrastructure as a service is the perfect fit here, let's dig into what makes each cloud service model unique. A financial institution needing to customize their Linux kernel for a trading algorithm is like a master chef who needs to build their kitchen from scratch. They need control over every single component, from the foundation up. Infrastructure as a service, or IaaS, gives you a virtual data center where you control everything from the operating system upward, including that crucial ability to modify the kernel, the core of the operating system that controls how software interacts with hardware. This level of control is essential for specialized applications, like trading algorithms that need microsecond-level optimizations. Software as a service would only give you a finished application with no access to the underlying system. Platform as a service manages the operating system for you, which prevents any kernel modifications. And function as a service only runs small pieces of code without any system access. Only IaaS provides the complete control needed while still leveraging cloud benefits like scalability and reduced hardware management. 3. Your healthcare organization needs to share cloud infrastructure with other hospitals while maintaining HIPAA compliance isolation. Which deployment model specifically addresses this multi-organization requirement with regulatory considerations? A. Public cloud. B. Private cloud. C. Community cloud. D. Hybrid cloud. Can you guess the answer? Correct answer, C. Community cloud. Explanation. Option C is correct because community cloud serves specific communities with shared compliance requirements while maintaining isolation from other industries. Option A is incorrect because public clouds share infrastructure with all types of organizations, not maintaining industry-specific isolation for compliance. Option B is incorrect because private clouds serve only a single organization, not enabling cost-effective sharing among similar organizations. Option D is incorrect because hybrid clouds combine different deployment models, but don't specifically address shared compliance requirements among peers. This is a critical concept for understanding specialized cloud deployments. When multiple healthcare organizations need to share cloud infrastructure while maintaining strict HIPAA compliance, they face a unique challenge. They need the cost benefits of sharing resources, but can't mix their data with non-healthcare organizations that don't have the same regulatory requirements. Community cloud is specifically designed for this scenario. Think of it as an exclusive club where only members from the same industry with identical compliance needs can join. In this healthcare community cloud, all participating hospitals share the infrastructure costs and benefits, but the entire environment is isolated from other industries and configured specifically for HIPAA compliance. A public cloud would mix healthcare data with all types of organizations, creating compliance risks. A private cloud serves only one organization, eliminating the cost-sharing benefits. A hybrid cloud combines different models, but doesn't create this industry-specific isolation. Only community cloud provides the perfect balance of shared costs and shared compliance requirements. 4. When migrating from traditional IT to cloud computing, which statement accurately describes the fundamental shift in data security responsibility regardless of the chosen service model? A. Providers handle everything. B. Customers retain liability. C. Responsibility transfers completely. D. Security becomes optional. Do you know the answer? Correct answer, B. Customers retain liability. Explanation. Option B is correct because customers always retain legal liability for their data, even when security implementation is shared with providers. Option A is incorrect because providers never assume complete responsibility for customer data security, only for infrastructure security in their scope. Option C is incorrect because responsibility for data liability never transfers to the cloud provider, only certain security control implementations. Option D is incorrect because security remains mandatory in cloud environments, with shared responsibilities clearly defined between parties involved. Understanding data liability in the cloud is absolutely fundamental to cloud security. Here's the crucial principle. No matter where your data lives or who manages the infrastructure, you as the data owner always retain ultimate legal liability for that data. Think of it like owning a valuable painting. Even if you store it in a bank's vault with their security guards and alarm systems, you're still the legal owner responsible if something happens to it. In cloud computing, this means that while providers handle various security controls and infrastructure protection, if there's a data breach affecting your customers' information, you're the one facing lawsuits, regulatory fines, and reputational damage. The provider might have contractual obligations and may share some technical responsibilities, but they can never assume your legal liability. This is why the shared responsibility model exists. It clearly defines who implements which security controls, but it never transfers the fundamental liability away from the data owner. 5. A startup needs back-end APIs, databases, and authentication without managing servers or operating systems. Which service model provides these capabilities while eliminating infrastructure management overhead? A. Infrastructure service. B. Platform service. C. Software service. D. Network service. Can you guess the answer? Correct answer, B. Platform service. Explanation: option B is correct because platform service provides development platforms with managed databases, authentication, and runtime environments without infrastructure responsibilities. Option A is incorrect because infrastructure service requires customers to manage operating systems, middleware, and all platform components above the infrastructure. Option C is incorrect because software service provides complete applications for end users, not development platforms for creating custom applications. Option D is incorrect because network service focuses on network connectivity and management, not application development platforms. Platform as a service is the sweet spot for developers who want to build applications without the infrastructure headaches. Imagine a startup that needs back-end APIs, databases, and authentication services. With Platform as a Service, all of these components come pre-configured and managed, like getting a fully equipped workshop where you just need to bring your creative ideas. PaaS provides the complete development and deployment environment in the cloud, including the operating system, middleware, development tools, database management systems, and authentication services, all maintained and patched by the provider. You focus solely on writing your application code and configuring your business logic. Infrastructure as a service would require you to install and manage everything yourself, including the operating system. Software as a service gives you finished applications, not development platforms, and network as a service only handles connectivity. PaaS hits that perfect balance, giving you powerful development capabilities without the burden of infrastructure management. 6. Your company processes customer data across multiple countries with different privacy laws. Which cloud computing challenge does this scenario primarily illustrate regarding compliance management? A. Performance degradation. B. Data sovereignty. C. Vendor lock-in. D. Service availability. Do you know the answer? Correct answer, B. Data sovereignty. Explanation: option B is correct, because data sovereignty involves data being subject to laws of the country where it's stored or processed. Option A is incorrect because performance degradation relates to system speed and responsiveness, not legal jurisdiction and compliance requirements. Option C is incorrect because vendor lock-in concerns difficulty switching providers due to proprietary technologies, not jurisdictional compliance issues. Option D is incorrect because service availability addresses uptime and accessibility of services, not cross-border legal compliance challenges. Data sovereignty is one of the most complex challenges in global cloud computing. When your company processes customer data across multiple countries, that data becomes subject to the laws of each country, where it's stored or processed. This is data sovereignty in action. Imagine customer data from France being processed in a US data center but accessed by users in Japan. This single dataset could potentially be subject to GDPR from Europe, US surveillance laws, and Japanese privacy regulations all at once. Each country asserts legal authority over data within its borders, regardless of who owns it or where the company is headquartered. This creates a compliance maze where you must understand and comply with potentially conflicting laws from multiple jurisdictions. Performance degradation is about speed, vendor lock-in is about switching providers, and service availability is about uptime. None of these address the fundamental legal jurisdiction challenge that data sovereignty represents. 7. An organization wants to maintain sensitive data on premises while using public cloud for web applications. Which deployment model enables this split architecture while maintaining connectivity between environments? A. Community deployment. B. Private deployment. C. Public deployment. D. Hybrid deployment. Do you know the answer? Correct answer, D. Hybrid deployment. Explanation: option D is correct because hybrid clouds combine private and public clouds, enabling sensitive data isolation while leveraging public cloud benefits. Option A is incorrect because community clouds serve multiple organizations with shared interests, not combining on-premises with public cloud resources. Option B is incorrect because private clouds are dedicated to single organizations but don't inherently combine with public cloud resources. Option C is incorrect because public clouds alone cannot maintain on-premises data while providing cloud services for other workloads. Hybrid cloud deployment is the architectural bridge between on-premises control and cloud flexibility. Picture an organization with sensitive data they absolutely must keep in their own data center for security or regulatory reasons, but they also want to leverage public cloud for their customer-facing web applications. Hybrid cloud makes this split architecture possible. It creates a unified environment where your on-premises infrastructure seamlessly connects with public cloud services, allowing data and applications to move between them as needed. This isn't just about using both environments separately, it's about creating an integrated architecture where they work together as one cohesive system. Community clouds serve shared organizations, private clouds are single organization only, and public clouds alone can't maintain that on-premises component. Only hybrid deployment enables you to keep sensitive data under your complete control while still benefiting from the scalability and cost-effectiveness of public cloud for appropriate workloads. 8. In the shared responsibility model, who maintains responsibility for hypervisor security in an infrastructure as a service deployment for customer virtual machines? A. Cloud customer. B. Cloud provider. C. Cloud broker. D. Cloud auditor. Do you know the answer? Correct answer, B. Cloud provider. Explanation: option B is correct because cloud providers are responsible for security of the cloud, including hypervisor security and infrastructure. So yeah. Option A is incorrect because customers are responsible for security in the cloud, such as operating systems and applications, not hypervisors. Option C is incorrect because cloud brokers facilitate relationships between providers and customers, but don't manage infrastructure security components. Option D is incorrect because cloud auditors assess security controls and compliance, but don't implement or maintain security measures. The shared responsibility model clearly defines security boundaries, and understanding who secures the hypervisor is crucial for IaaS deployments. The hypervisor is the foundational software layer that creates and manages virtual machines on physical servers. It's like the master conductor that ensures each VM operates in complete isolation from others on the same hardware. In infrastructure as a service, this hypervisor layer sits firmly in the provider's domain because it's part of the infrastructure itself, below the line where customer control begins. Cloud providers must secure this critical component because a compromised hypervisor could affect all customer VMs running on that physical server. Customers are responsible for everything from the operating system up. Their applications, data, and configurations, essentially security in the cloud. Providers handle security of the cloud, the physical facilities, hardware, hypervisor, and virtualization layer. Brokers facilitate relationships and auditors assess compliance, but neither manages infrastructure components. 9. A government agency requires absolute control over classified data infrastructure without any resource sharing. Which deployment model exclusively meets these stringent isolation and control requirements? A. Public cloud. B. Private cloud. C. Community cloud. D. Hybrid cloud. Can you guess the answer? Correct answer: B. Private cloud. Explanation. Option B is correct because private clouds provide dedicated resources for single organizations with no sharing, ensuring complete isolation. Option A is incorrect because public clouds involve multi-tenant resource sharing, which violates the requirement for exclusive resource control. Option C is incorrect because community clouds share resources among multiple organizations, even if they have similar security requirements. Option D is incorrect because hybrid clouds combine multiple models, including shared resources, not providing the required exclusive control. When absolute control and complete isolation are non-negotiable requirements, private cloud stands alone as the solution. A government agency handling classified data operates under the strictest security mandates. They need dedicated infrastructure that no other organization can access, period. Private cloud provides exactly this. It's like having your own personal data center that happens to use cloud technologies, where every server, storage device, and network component is exclusively yours. There's no multi-tenancy, no resource sharing with other organizations, and no possibility of data mingling with other customers' information. You have complete control over every aspect of the infrastructure, from physical security to logical access controls. Public clouds are built on shared infrastructure. Community clouds still involve multiple organizations, even if they're similar. And hybrid clouds include shared components. Only private cloud delivers the exclusive, dedicated resources that classified government operations demand. 10. Which technology enables cloud providers to run multiple isolated virtual machines on single physical servers, forming the foundation for resource pooling and multi-tenancy? A. Containerization technology. B. Virtualization technology. C. Orchestration technology. D. Encryption technology. Do you know the answer? Correct answer: B. Virtualization technology. Explanation. Option B is correct because virtualization allows multiple virtual machines to run on single physical servers with isolation, enabling resource pooling. Option A is incorrect because containerization shares operating system kernels between containers, not providing the same isolation level as virtualization. Option C is incorrect because orchestration manages and coordinates resources but doesn't create the isolated environments on physical hardware. Option D is incorrect because encryption protects data confidentiality but doesn't enable multiple isolated environments on single servers. Virtualization technology is the foundational magic that makes cloud computing possible. At its core, virtualization allows one physical server to run multiple, completely isolated virtual machines simultaneously. Imagine one powerful computer pretending to be 10 separate computers, each unaware of the other's existence. This is achieved through a hypervisor that creates these virtual environments, allocating CPU, memory, and storage from the physical hardware to each VM while maintaining complete isolation between them. This isolation is critical for multi-tenancy and cloud environments, where different customers' workloads run on the same physical hardware, without any risk of data leakage or interference. Containerization shares operating system kernels between containers, so it doesn't provide the same level of isolation. Orchestration manages resources but doesn't create the virtual environments. And encryption protects data but doesn't enable virtualization. Only virtualization technology provides the foundation for securely sharing physical resources among multiple isolated tenants. 11. When evaluating cloud storage options, which type best suits unstructured data like videos, images, and backups with internet-accessible URLs for each item? A. Block storage. B. Object storage. C. File storage. D. Database storage. Can you guess the answer? Correct answer, B. Object storage. Explanation: option B is correct because object storage is designed for unstructured data, providing URL access and scalability for media files. Option A is incorrect because block storage provides raw storage volumes for structured data, typically attached to virtual machines for file systems. Option C is incorrect because file storage provides hierarchical file systems for shared access, not optimized for large, unstructured data. Option D is incorrect because database storage is structured for relational or document data with queries, not unstructured media files. Object storage revolutionized how we handle massive amounts of unstructured data in the cloud. Think of object storage as a massive warehouse where each item, whether it's a video, image, or backup file, gets its own unique address label that can be accessed directly from anywhere on the internet. Unlike traditional file systems with folders and hierarchies, object storage uses a flat namespace where every object has a unique URL, making it perfect for content that needs to be distributed globally. Each object is stored with its metadata as a complete package, and the system can scale to billions of objects without performance degradation. Block storage provides raw volumes for databases and needs to be attached to specific VMs. File storage maintains hierarchical folder structures for shared access, and database storage is highly structured for relational data. Object storage's combination of unlimited scalability, direct URL access, and optimization for large unstructured files makes it the ideal choice for media content and backups. 12. Your organization needs to track cloud spending by department and project while preventing budget overruns. Which cloud characteristic directly enables this financial visibility and control? A. On-demand self-service. B. Measured service. C. Broad network access. D. Resource pooling. Do you know the answer? Correct answer, B. Measured service. Explanation: option B is correct because measured service provides detailed usage tracking and billing information, enabling cost control by department. Option A is incorrect because on-demand self-service enables resource provisioning without human intervention, but doesn't inherently track costs by department or project. Option C is incorrect because broad network access provides universal connectivity to services, but doesn't directly measure or track usage costs for financial control. Option D is incorrect because resource pooling shares physical resources among multiple customers, but doesn't provide detailed cost tracking and allocation by department or project. Measured service is the cloud characteristic that transforms IT from a black box expense into transparent, trackable spending. Imagine trying to split a restaurant bill among different departments in your company. Measured service is like getting an itemized receipt that shows exactly what each department ordered, when they ordered it, and how much it cost. In cloud computing, this means every resource consumption is monitored, controlled, and reported with complete transparency. CPU hours, storage gigabytes, network bandwidth. Everything is tracked with precision. This granular measurement enables organizations to allocate costs accurately by department and project, set budget alerts to prevent overruns, and optimize spending by identifying waste. On-demand self-service lets you provision resources, broad network access provides connectivity, and resource pooling shares infrastructure. But only measured service provides the detailed financial visibility and control that enables departmental cost tracking and budget management. 13. A marketing agency needs CRM capabilities without managing any infrastructure, databases, or software updates. Which service model provides complete application functionality through web browsers only? A. Infrastructure service. B. Platform service. C. Software service. D. Desktop service. Can you guess the answer? Correct answer, C. Software service. Explanation. Option C is correct because software as a service provides complete applications, accessed through browsers with all infrastructure and maintenance handled by providers. Option A is incorrect because infrastructure as a service requires customers to install and manage all software, including operating systems and applications themselves. Option B is incorrect because platform as a service provides development platforms, requiring customers to build and deploy their own applications on top. Option D is incorrect because desktop as a service provides virtual desktops, but still requires application management and configuration. Software as a service represents the ultimate in simplicity for end users who just need working applications. A marketing agency needing CRM capabilities through SaaS is like subscribing to Netflix. You open your browser, log in, and everything just works without any thought about servers, databases, or software updates. The SaaS provider handles absolutely everything technical: the infrastructure, operating systems, databases, application code, updates, patches, backups, and scaling. Users simply access the finished application through their web browser, focusing entirely on using the software for their business needs rather than managing it. Infrastructure as a service requires you to build everything from the OS up. Platform as a service still needs you to develop and deploy applications. And desktop as a service provides virtual desktops but requires application management. SaaS eliminates all technical responsibilities, providing complete, ready-to-use applications with zero infrastructure management. 14. Which cloud role provides independent third-party validation of security controls against frameworks like ISO 27001 and SOC2 for compliance verification? A. Cloud broker. B. Cloud auditor. C. Cloud carrier. D. Cloud customer. Do you know the answer? Correct answer, B. Cloud auditor. Explanation. Option B is correct because cloud auditors conduct independent assessments of security controls and compliance against established frameworks and standards. Option A is incorrect because cloud brokers facilitate relationships and service selection between providers and customers, not security assessments. Option C is incorrect because cloud carriers provide network connectivity and transport services, not security control validation or assessments. Option D is incorrect because cloud customers consume services and are responsible for their data but don't provide independent validation. Cloud auditors serve as the independent verification layer in cloud security, much like financial auditors validate company books. When organizations need to prove their cloud security meets standards like ISO 27001 or SOC2, they can't just self-certify. They need an independent third party with no stake in the outcome to thoroughly examine and validate their controls. Cloud auditors perform systematic evaluations of security implementations, checking everything from access controls to encryption practices against established frameworks. They produce formal attestation reports that regulators and customers can trust because the auditor has no conflict of interest. Cloud brokers help select services, carriers provide network connectivity, and customers consume services, but none of these roles can provide the independent, unbiased validation that compliance requires. Only cloud auditors possess the independence and expertise to formally verify that security controls meet regulatory and industry standards. 15. An online education platform experiences predictable traffic spikes during evening hours across time zones. Which cloud characteristic eliminates the need for permanent peak capacity infrastructure? A. Rapid elasticity. B. Resource pooling. C. Measured service. D. Broad access. Can you guess the answer? Correct answer, A. Rapid elasticity. Explanation: option A is correct because rapid elasticity allows the platform to automatically increase resources during peak hours and decrease them during off-peak hours, avoiding the need to maintain infrastructure for the highest possible load at all times. Option B is incorrect because resource pooling allows multiple customers to share the same infrastructure, but it does not automatically adjust capacity based on demand fluctuations for a specific platform. Option C is incorrect because measured service is about tracking and billing for resource usage, not about dynamically adjusting resource allocation based on demand. Option D is incorrect because broad access simply means the platform can be accessed from various devices and locations. It does not address the issue of scaling resources to meet demand. Online education platforms face predictable yet dramatic traffic patterns that make rapid elasticity essential. Picture this: every evening as time zones roll into prime study hours, traffic surges like a predictable tide. Students in Asia log on at 7 p.m. their time, then Europeans, then Americans, creating waves of demand that would require massive permanent infrastructure if handled traditionally. Rapid elasticity acts like an intelligent accordion for your infrastructure, automatically expanding to accommodate thousands of concurrent students during peak evening hours, then contracting during quiet periods to minimize costs. This automatic scaling happens in real time without human intervention, ensuring students never experience slowdowns, while the platform never pays for unused capacity. Resource pooling efficiently shares resources but doesn't adjust individual capacity. Measured service tracks usage but doesn't scale automatically. And broad access provides connectivity but doesn't address capacity needs. Rapid elasticity uniquely solves the peak capacity challenge without permanent infrastructure investment. 16. In cloud computing, what fundamental principle states that customers can never transfer legal accountability for their data to cloud providers? A. Shared responsibility. B. Data ownership. C. Liability retention. D. Risk transfer. Do you know the answer? Correct answer, C. Liability retention. Explanation: option C is correct because organizations always retain liability for their data, regardless of where it's stored or processed. Option A is incorrect because shared responsibility defines security task division, but does not address the non-transferable nature of data liability. Option B is incorrect because data ownership refers to who owns the data, but does not specifically address legal liability aspects. Option D is incorrect because risk transfer involves insurance or contractual arrangements, but cannot transfer fundamental data protection liability. Liability retention is a fundamental legal principle that many organizations misunderstand about cloud computing. Here's the unchangeable reality. You can outsource the work, but you can never outsource the accountability. When customer data is breached, regulators and courts don't sue the cloud provider. They come after the data owner because legal liability for data protection cannot be transferred through any contract or agreement. Think of it like hiring a moving company. If they damage your furniture, you might have a claim against them, but you're still the one who has to deal with the consequences, and you're still the owner responsible for the items. In cloud computing, this means that while providers implement security controls and may have contractual obligations, the fundamental legal liability for data breaches, regulatory violations, and customer harm always stays with the organization that owns the data. Shared responsibility defines task division, but liability retention ensures accountability never transfers. 17. Your company wants to combine services from multiple cloud providers to optimize costs and avoid vendor lock-in. Which role specializes in this integration? A. Cloud provider. B. Cloud broker. C. Cloud carrier. D. Cloud auditor. Can you guess the answer? Correct answer, B. Cloud broker. Explanation: option B is correct because cloud brokers manage relationships between multiple providers and help integrate services for optimal solutions. Option A is incorrect because cloud providers offer services directly, but don't typically integrate competitor services for customer optimization. Option C is incorrect because cloud carriers provide network connectivity between customers and providers, not service integration and optimization. Option D is incorrect because cloud auditors assess security and compliance, but don't actively integrate or manage multiple provider relationships. Cloud brokers are the master integrators of the multi-cloud world, solving one of modern IT's biggest challenges. When companies want to use AWS for compute, Google Cloud for AI services, and Azure for databases to optimize costs and avoid vendor lock-in, they need someone who speaks all these languages fluently. Enter the cloud broker. These specialized intermediaries understand the strengths, weaknesses, pricing models, and integration points of different providers, acting like a skilled conductor who brings together different sections of an orchestra to create harmony. They help organizations select the best services from each provider, negotiate contracts, manage relationships, and most importantly, integrate these disparate services into a cohesive solution. Cloud providers focus on their own services, carriers provide connectivity, and auditors assess security, but only cloud brokers specialize in weaving together services from multiple providers into an optimized, unified architecture. 18. A development team needs to test applications across multiple operating systems without purchasing hardware. Which service model provides this capability most cost-effectively? A. Software service. B. Platform service. C. Infrastructure service. D. Testing service. Do you know the answer? Correct answer, C. Infrastructure service. Explanation: option C is correct because infrastructure service allows installing multiple operating systems on virtual machines for testing without hardware investment. Option A is incorrect because software service provides finished applications for use, not testing environments with multiple operating system options. Option B is incorrect because platform service provides managed platforms with predetermined operating systems, not flexibility to install various operating system versions. Option D is incorrect because testing service focuses on test automation and management, not providing multiple operating system environments. When developers need maximum testing flexibility without hardware investments, infrastructure as a service delivers exactly what's needed. Imagine a development team that needs to test their application on Windows Server, Ubuntu, Red Hat Linux, and Mac OS. With IaaS, they can spin up virtual machines running any operating system they need within minutes, run their tests, and then delete them when done. Infrastructure as a service provides raw compute resources where you have complete control over the operating system choice and configuration, making it perfect for testing scenarios that require different OS environments. You're not locked into predetermined platforms or operating systems. You can install whatever you need, configure it however you want, and pay only for the time you use it. Software as a service provides finished applications, Platform as a service locks you into specific OS choices. And testing as a service focuses on test automation, not OS flexibility. IaaS provides the cost-effective, flexible foundation for comprehensive multi-OS testing. 19. Which security model clearly defines that providers secure physical data centers while customers secure their applications and data within the cloud? A. Zero trust model. B. Shared responsibility model. C. Defense in depth model. D. Perimeter security model. Can you guess the answer? Correct answer, B. Shared responsibility model. Explanation. Option B is correct because the shared responsibility model explicitly delineates security duties between providers and customers by layer. Option A is incorrect because zero trust model assumes no trust and verifies everything, but does not define provider versus customer responsibilities. Option C is incorrect because defense in depth uses multiple security layers, but does not specify who implements each layer in cloud. Option D is incorrect because perimeter security focuses on network boundaries, which dissolve in cloud environments requiring different approaches. The shared responsibility model is the cornerstone of cloud security, establishing crystal clear boundaries between provider and customer duties. Think of it like renting an apartment. The landlord secures the building, maintains the locks, and ensures the structure is sound, while you're responsible for not leaving your door unlocked and protecting your belongings inside. In cloud computing, providers secure the physical data centers, network infrastructure, hypervisors, and hardware, essentially everything that makes up the cloud itself. Customers secure their applications, data, user access, and configurations, everything they put into the cloud. This model explicitly defines these boundaries to eliminate confusion about who handles what. Zero trust assumes no trust anywhere, defense in depth uses multiple layers, and perimeter security focuses on boundaries. But only the shared responsibility model specifically delineates the security division between providers and customers. 20. An enterprise requires dedicated network connections to cloud providers for mission-critical applications avoiding public internet. Which role provides this connectivity infrastructure? A. Cloud broker. B. Cloud carrier. C. Cloud provider. D. Cloud auditor. Do you know the answer? Correct answer, B. Cloud carrier. Explanation. Option B is correct because cloud carriers are telecommunications companies providing network infrastructure, including dedicated connections to cloud providers. Option A is incorrect because cloud brokers facilitate service selection and integration but do not provide physical network infrastructure or a connectivity. Option C is incorrect because cloud providers offer computing services but typically do not provide the network connectivity infrastructure to reach them. Option D is incorrect because cloud auditors assess compliance and security but do not provide any network infrastructure or connectivity services. Cloud carriers are the unsung heroes providing the critical network highways that connect businesses to their cloud providers. When an enterprise needs dedicated, high-speed connections to cloud services for mission-critical applications that can't tolerate the unpredictability of public internet, cloud carriers step in with solutions like dedicated fiber connections, MPLS circuits, and direct peering arrangements. These telecommunications companies provide the physical network infrastructure, the actual cables, routers, and network paths that create private, reliable connections between customer data centers and cloud providers. Think of them as building private toll roads directly to the cloud, bypassing the congested public internet highways. Cloud brokers facilitate service selection, providers offer computing services, and auditors assess security, but only cloud carriers provide the actual network infrastructure and dedicated connectivity that mission-critical applications require. 21. Your organization must comply with GDPR, requiring data to remain within European borders. Which cloud concept directly addresses this geographic restriction requirement? A. Data residency. B. Data classification. C. Data encryption. D. Data masking. Can you guess the answer? Correct answer A. Data residency. Explanation. Option A is correct because data residency requirements specify geographic boundaries where data must be stored and processed for compliance. Option B is incorrect because data classification categorizes data by sensitivity levels but doesn't address geographic storage location requirements. Option C is incorrect because data encryption protects data confidentiality but doesn't ensure it remains within specific geographic boundaries. Option D is incorrect because data masking obscures sensitive data for non-production use but doesn't control geographic storage locations. Data residency requirements represent the geographic boundaries of data sovereignty in action. When GDPR mandates that European citizen data must remain within European borders, this isn't just a suggestion, it's a legal requirement with severe penalties for violations. Data residency specifically addresses where data physically resides and is processed, ensuring it stays within defined geographic boundaries to comply with regional laws. This means organizations must know exactly which data centers their data inhabits and ensure those locations align with regulatory requirements. Cloud providers offer region selection and data residency guarantees specifically to address these requirements. Data classification categorizes sensitivity levels, encryption protects data confidentiality, and masking obscures sensitive fields, but none of these ensure data stays within required geographic boundaries. Only data residency controls directly address the fundamental requirement of keeping data within specific geographic limits for regulatory compliance. 22. A startup wants to avoid large upfront IT investments while maintaining flexibility to scale. Which cloud financial benefit directly addresses this business requirement? A. Predictable pricing. B. Volume discounts. C. Operational expenditure model. D. Reserved instances. Do you know the answer? Correct answer C. Operational expenditure model. Explanation. Option C is correct because the operational expenditure model eliminates capital investments while providing pay-as-you-go flexibility for scaling needs. Option A is incorrect because predictable pricing helps with budgeting, but doesn't eliminate the need for upfront capital investments. Option B is incorrect because volume discounts reduce costs for large usage, but still may require upfront commitments or investments. Option D is incorrect because reserved instances require upfront commitments for discounts, contradicting the need to avoid upfront investments. The shift from capital expenditure to operational expenditure represents a financial revolution for startups, and growing businesses. Traditional IT requires massive upfront capital investments, buying servers, storage, networking equipment, and data center space before you can even begin operations, like having to buy an entire fleet of trucks before starting a delivery business. The OpEx model in cloud computing transforms this completely. Instead of buying infrastructure, you rent it by the hour, paying only for what you use as an operational expense. This eliminates the need for large capital investments while providing complete flexibility to scale up or down based on actual business needs. For startups with limited capital, this means they can launch with enterprise-grade infrastructure while preserving cash for growth. Predictable pricing helps budgeting, volume discounts reduce costs, and reserved instances offer savings, but only the OpEx model fundamentally eliminates upfront capital requirements while maintaining scaling flexibility. 23. When transitioning to cloud computing, Which virtualization component manages resource allocation and isolation between multiple virtual machines on physical hardware? A. Container engine. B. Hypervisor layer. C. Operating system. D. Application runtime. Can you guess the answer? Correct answer, B. Hypervisor layer. Explanation: option B is correct because the hypervisor manages virtual machine resource allocation, isolation, and translation between virtual and physical resources. Option A is incorrect because container engines manage containers which share operating system kernels, not full virtual machine isolation. Option C is incorrect because operating systems run within virtual machines but do not manage the virtualization layer itself or resource allocation. Option D is incorrect because application runtime executes applications within operating systems but does not manage virtual machine resources or isolation. The hypervisor layer is the critical virtualization component that makes cloud computing possible at scale. Acting as the master controller between physical hardware and virtual machines, the hypervisor manages every aspect of resource allocation, determining how much CPU, memory, and storage each VM receives while ensuring complete isolation between them. Think of it as a strict apartment building manager who assigns rooms, ensures soundproof walls between tenants, and manages shared utilities without any tenant knowing about the others. The hypervisor translates virtual resource requests into physical hardware operations, maintains security boundaries between VMs, and enables live migration of VMs between physical servers. Container engines manage containers but share OS kernels. Operating systems run within VMs but don't manage virtualization. An application runtime executes programs but doesn't control VM resources. Only the hypervisor layer provides the essential resource management and isolation that enables secure multi-tenancy and cloud environments. 24. Which cloud characteristic ensures that Bangkok-based employees can access the same cloud services as New York colleagues using standard web browsers? A. Rapid elasticity. B. Broad network access. C. Resource pooling. D. Measured service. Do you know the answer? Correct answer, B. Broad network access. Explanation: option B is correct because broad network access ensures services are accessible globally through standard mechanisms regardless of location. Option A is incorrect because rapid elasticity refers to the ability to quickly increase or decrease resources as needed, not the accessibility of the services. Option C is incorrect because resource pooling is about sharing resources among multiple users, not ensuring that users can access the same services from anywhere. Option D is incorrect because measured service is about tracking and billing for the resources used, not ensuring that users can access the same services from anywhere. Broad network access ensures cloud services are universally accessible, breaking down geographic and device barriers. This characteristic means that whether you're in Bangkok or Boston, using a laptop or smartphone, connecting through corporate networks or coffee shop Wi-Fi, you can access the same cloud services through standard mechanisms like web browsers and APIs. It's the cloud characteristic that makes location irrelevant. Your office is wherever you have internet connectivity. The cloud doesn't care about your physical location or device type. It provides consistent service access through standardized protocols that work everywhere. This universal accessibility is what enables global teams to collaborate seamlessly, employees to work from anywhere, and businesses to serve customers worldwide. Rapid elasticity handles scaling, resource pooling optimizes infrastructure, and measured service tracks usage, but broad network access specifically ensures that geographic location never becomes a barrier to service access. 25. An insurance company needs to implement disaster recovery with data replication across regions while maintaining some on-premises systems. Which deployment model supports this architecture? A. Private cloud. B. Public cloud. C. Community cloud. D. Hybrid cloud. Can you guess the answer? Correct answer, D. Hybrid cloud. Explanation: option D is correct because hybrid cloud combines on-premises systems with cloud resources enabling geographic distribution for disaster recovery. Option A is incorrect because private cloud alone doesn't inherently provide geographic distribution across regions for disaster recovery purposes. Option B is incorrect because public cloud alone doesn't maintain on-premises systems as required by the insurance company's architecture. Option C is incorrect because community cloud serves multiple organizations with shared needs, but doesn't combine on-premises with cloud. Hybrid cloud architecture perfectly addresses the complex needs of disaster recovery while maintaining existing on-premises investments. An insurance company implementing disaster recovery faces a critical challenge. They need geographic distribution to protect against regional disasters, but they also have legacy systems and regulatory requirements that keep some data on premises. Hybrid cloud creates a unified disaster recovery architecture where on-premises data is continuously replicated to cloud regions, providing geographic separation essential for true disaster protection. When disaster strikes the primary site, workloads can fail over to the cloud automatically, ensuring business continuity. Meanwhile, the organization maintains control over sensitive systems that must stay on premises for regulatory or technical reasons. Private cloud alone lacks geographic distribution. Public cloud alone abandons on-premises systems, and community cloud serves shared organizations but doesn't combine on-premises with cloud. Hybrid cloud uniquely enables comprehensive disaster recovery across geographically distributed infrastructure while preserving on-premises requirements. 26. Your company experiences a viral social media campaign, increasing website traffic by 500% within hours. Which cloud characteristic prevents service outages during this spike? A. On-demand self-service. B. Rapid elasticity. C. Measured service. D. Broad access. Do you know the answer? Correct answer, B. Rapid elasticity. Explanation: option B is correct because rapid elasticity automatically scales resources within minutes to handle sudden traffic spikes, preventing outages. Option A is incorrect because on-demand self-service enables manual resource provisioning, but doesn't automatically handle sudden traffic spikes. Option C is incorrect because measured service tracks the increased usage for billing, but doesn't automatically provision additional resources. Option D is incorrect because broad access provides universal connectivity, but doesn't add capacity to handle increased traffic loads. Let's examine how rapid elasticity becomes a business lifesaver during viral social media moments. When your company's product suddenly goes viral and website traffic explodes by 500% within hours, you're facing every IT manager's nightmare and dream simultaneously. Massive customer interest that could crash your systems. Traditional infrastructure would simply buckle under this unexpected load, turning eager customers into frustrated users encountering error messages. Rapid elasticity operates like an emergency response system for your infrastructure, automatically detecting the traffic surge and instantly provisioning additional servers, bandwidth, and resources to handle the load. This happens within minutes without any human intervention. The system recognizes the spike and scales accordingly. While on-demand self-service requires manual provisioning, measured service only tracks the usage increase, and broad access provides connectivity, but not capacity. Rapid elasticity uniquely provides the automatic, immediate scaling that prevents outages during unexpected traffic explosions. 27. In software as a service, which party is responsible for patching and updating the application software that end users directly interact with daily? A. Cloud customer, B. Cloud provider, C. Cloud broker, D. End users. Can you guess the answer? Correct answer, B. Cloud provider. Explanation: option B is correct because in SaaS the providers handle all aspects including application updates, patches, and maintenance for users. Option A is incorrect because cloud customers only manage their data and user access in SaaS, not application software maintenance. Option C is incorrect because cloud brokers facilitate service selection and integration, but do not maintain or update application software. Option D is incorrect because end users consume the service but have no responsibility for software updates or maintenance. In the software as a service model, understanding who patches the application is crucial for security planning. When you use SaaS applications like Salesforce, Office 365, or Zoom, the provider takes complete ownership of application maintenance, including all patches, updates, and security fixes. This is like living in a full-service apartment where maintenance handles everything from plumbing to electrical work. You just live there and use the facilities. The SaaS provider continuously monitors for vulnerabilities, develops patches, tests them thoroughly, and deploys them across their entire infrastructure, often without users even noticing. Customers simply log in and find improved, secured applications without lifting a finger. This complete provider responsibility for application maintenance is what makes SaaS so attractive for organizations that want to focus on using software rather than maintaining it. Cloud brokers facilitate selection, and end users consume the service, but in SaaS, the provider alone bears responsibility for application patching. 28. A financial firm needs low-latency storage directly attached to virtual machines for database operations. Which storage type best meets this performance requirement? A. Object storage, B. Block storage, C. Archive storage, D. Tape storage. Do you know the answer? Correct answer, B. Block storage. Explanation: option B is correct because block storage provides raw, low-latency storage volumes that attach directly to VMs for databases. Option A is incorrect because object storage is optimized for unstructured data with URL access, not low-latency database operations. Option C is incorrect because archive storage prioritizes cost over performance for rarely accessed data, unsuitable for active databases. Option D is incorrect because tape storage is offline backup media with very high latency, completely unsuitable for database operations. Financial firms running databases need the fastest, most direct storage possible, and block storage delivers exactly that performance. Block storage provides raw, unformatted storage volumes that attach directly to virtual machines, functioning exactly like a physical hard drive connected to a server. For database operations requiring microsecond response times, this direct attachment and low latency access is critical. The data travels the shortest possible path between storage and compute. Think of it as having your filing cabinet right next to your desk versus having to walk to another building. The proximity matters when you need information thousands of times per second. Block storage presents storage as raw blocks that the operating system formats and manages, providing the flexibility and performance databases demand. Object storage uses URLs and is optimized for unstructured data, archive storage prioritizes cost over speed, and tape storage is offline with extreme latency. Only block storage provides the low latency, direct attached performance that database operations require. 29. Which security concern arises when multiple organizations share the same physical infrastructure in public cloud environments requiring careful isolation controls? A. Multi-tenancy risks. B. Single points failure. C. Geographic dispersion. D. Time zone differences. Can you guess the answer? Correct answer, A. Multi-tenancy risks. Explanation. Option A is correct because multi-tenancy risks arise when multiple customers share physical infrastructure, requiring strong isolation controls for security. Option B is incorrect because single points of failure relate to availability and redundancy, not security isolation between different customers. Option C is incorrect because geographic dispersion actually improves availability and disaster recovery, rather than creating security concerns. Option D is incorrect because time zone differences affect operational coordination, but don't create security risks from shared infrastructure. Multi-tenancy risks represent one of cloud computing's fundamental security challenges that requires sophisticated isolation controls. When multiple organizations share the same physical servers in public clouds, they're like apartment dwellers sharing the same building. The walls between units must be absolutely solid to prevent any leakage between neighbors. In cloud infrastructure, different customers' virtual machines run on the same physical hardware, separated only by virtualization technology and security controls. If these isolation mechanisms fail, one customer could potentially access another's data, or a compromised VM could attack its neighbors on the same host. This is why cloud providers implement multiple layers of isolation, including hypervisor security, network segmentation, and memory isolation. Single points of failure relate to availability, geographic dispersion improves resilience, and time zones affect operations. But multi-tenancy risks specifically arise from the shared infrastructure model that defines public cloud computing. 30. An organization wants to transform large capital expenditures for data centers into predictable monthly operational costs. Which cloud benefit enables this? A. Scalability improvement. B. Metered service billing. C. Performance optimization. D. Automation capabilities. Do you know the answer? Correct answer, B. Metered service billing. Explanation. Option B is correct because metered service billing enables pay-as-you-go operational expenses, replacing large capital infrastructure investments. Option A is incorrect because scalability improvement enhances the ability to grow, but doesn't specifically transform capital into operational expenses. Option C is incorrect because performance optimization improves system efficiency, but doesn't change the financial model from capital expenditure to operational expenditure. Option D is incorrect because automation capabilities reduce manual work, but don't directly transform capital expenditures to operational costs. Metered service billing transforms the financial model of IT from unpredictable capital expenses to manageable operational costs. For organizations wanting to convert massive data center investments into predictable monthly bills, metered service billing acts like switching from buying a house to renting an apartment with utilities included. Every resource consumed, compute hours, storage gigabytes, network transfers, is precisely measured and billed as an operational expense. This pay-as-you-go model means no more million-dollar server purchases sitting as depreciating assets on balance sheets. Instead, infrastructure becomes a monthly line item like electricity or water, scaling with actual usage. This transformation is particularly powerful for CFOs who can now forecast IT costs based on business activity rather than guessing at capacity needs years in advance. While scalability improves growth potential and automation reduces manual work, metered service billing specifically enables the CapEx to OpEx transformation. 31. Your development team needs pre-configured databases, authentication services, and automatic scaling without managing operating systems. Which service model provides these platform capabilities? A. Infrastructure service. B. Platform service. C. Software service. D. Database service. Can you guess the answer? Correct answer, B. platform service. Explanation: option B is correct because platform as a service provides managed platforms with databases, authentication, and scaling while abstracting operating system management away. Option A is incorrect because infrastructure as a service requires customers to install and manage their own databases, authentication, and operating systems. Option C is incorrect because software as a service provides complete finished applications for end users, not development platforms with component services. Option D is incorrect because database as a service is a subset of platform as a service, not providing authentication and other platform services. Platform as a service hits the sweet spot for development teams needing robust capabilities without infrastructure complexity. When your team needs databases, authentication services, and automatic scaling, PaaS provides these as pre-configured, managed services that work together seamlessly. It's like getting a professional kitchen where all appliances are installed, maintained, and upgraded by someone else. You just cook. The platform provider manages the entire stack below your application. The operating system with its endless patches, the middleware connecting everything together, the runtime environments for your code, and services like databases and authentication. Your developers focus purely on writing business logic and building features that differentiate your product. Infrastructure as a service would require managing everything yourself. Software as a service gives you finished apps, not development platforms. And database as a service is just one component of what PaaS provides. Platform as a service delivers the complete development ecosystem without the infrastructure burden. 32. Which principle ensures that cloud users have minimum necessary permissions to perform their job functions, reducing potential security breach impact? A. Least privilege. B. Defense depth. C. Zero trust. D. Separation duties. Do you know the answer? Correct answer: A. Least privilege. Explanation: option A is correct because the least privilege principle ensures users only have the minimum permissions necessary for their specific job functions. Option B is incorrect because defense in depth uses multiple security layers but doesn't specifically address user permission minimization. Option C is incorrect because zero trust verifies everything but doesn't specifically define the minimum permission allocation principle. Option D is incorrect because separation of duties divides critical tasks among multiple people but doesn't minimize individual permissions. The principle of least privilege is security's golden rule for minimizing breach impact in cloud environments. This principle dictates that every user, application, and service should have exactly the minimum permissions necessary to perform their specific job. Nothing more, nothing less. Imagine giving someone keys to your house. Least privilege means giving them a key only to the front door, not a master key to every room, safe, and cabinet. In cloud environments, this translates to giving a developer read access to specific databases they work with, not admin access to all databases. If their account is compromised, the attacker can only access what that specific account could access, dramatically limiting the blast radius of a breach. Defense in depth creates multiple security layers, zero trust verifies everything, and separation of duties divides tasks, but least privilege specifically minimizes each user's permissions to reduce potential damage. 33. A hospital group wants to share cloud resources with other healthcare providers while maintaining HIPAA compliance. Which deployment model serves this specific community need? A. Public deployment. B. Private deployment. C. Community deployment. D. Hybrid deployment. Can you guess the answer? Correct answer: C. Community deployment. Explanation: option C is correct because community clouds serve organizations with shared compliance needs, like HIPAA, while maintaining industry isolation. Option A is incorrect because public clouds mix all industries together without maintaining healthcare-specific compliance isolation requirements. Option B is incorrect because private clouds serve single organizations only, preventing cost-effective sharing among similar healthcare providers. Option D is incorrect because hybrid clouds combine models but don't specifically create industry-specific communities with shared compliance. Community cloud deployment creates exclusive clubs for organizations with identical compliance requirements. When hospitals need to share cloud resources while maintaining HIPAA compliance, they can't simply use public clouds where their sensitive health data might share infrastructure with retail or entertainment companies. Community cloud creates a dedicated environment exclusively for healthcare organizations, where every participant operates under the same strict HIPAA requirements. This shared environment is configured specifically for healthcare compliance. Encryption standards, audit logging, access controls, all tailored to HIPAA specifications. The participating hospitals share the costs of this specialized infrastructure, making it more affordable than individual private clouds, while maintaining industry-specific isolation. Public clouds mix all industries together. Private clouds serve single organizations without cost sharing. And hybrid clouds combine models without creating specialized communities. Community cloud uniquely serves organizations with shared compliance needs. 34. When using infrastructure as a service, which security component remains entirely under customer control, requiring careful configuration and maintenance? A. Physical security. B. Hypervisor security. C. Operating system. D. Network hardware. Do you know the answer? Correct answer, C. Operating system. Explanation. Option C is correct because in IaaS, customers have complete responsibility for operating system installation, configuration, and security patches. Option A is incorrect because physical security of data centers is always the cloud provider's responsibility in any service model. Option B is incorrect because hypervisor security is managed by the cloud provider as part of the infrastructure layer. Option D is incorrect because network hardware is physical infrastructure managed by the cloud provider, not the customer's responsibility. In infrastructure as a service, the operating system represents the critical boundary of customer responsibility. When you provision a virtual machine in IaaS, the provider gives you raw compute resources with virtualization, but from the operating system upward, everything becomes your domain. You must install the OS, configure it, harden it against attacks, apply security patches, manage user accounts, and monitor for threats. This is like renting an empty office space. The building management provides the structure and utilities, but you're responsible for everything you put inside. The operating system is particularly critical because it's the foundation for all your applications and services. A compromised OS means everything running on it is at risk. Physical security, hypervisors, and network hardware remain the provider's responsibility as part of the infrastructure. In IaaS, the OS is where customer control and responsibility truly begin. 35. Your company needs to process encrypted data without decrypting it first for regulatory compliance. Which emerging technology potentially enables this capability? A. Homomorphic encryption. B. Symmetric encryption. C. Asymmetric encryption. D. Transport encryption. Can you guess the answer? Correct answer, A. Homomorphic encryption. Explanation. Option A is correct, because homomorphic encryption theoretically allows computations on encrypted data without requiring decryption first. Option B is incorrect because symmetric encryption requires decryption before processing, using the same key for encryption and decryption. Option C is incorrect because asymmetric encryption uses key pairs but still requires decryption before data can be processed. Option D is incorrect because transport encryption protects data in transit but must be decrypted at endpoints for processing. Homomorphic encryption represents the holy grail of cloud data security, the ability to process encrypted data without ever decrypting it. Imagine being able to perform calculations on data that's locked in a safe without ever opening the safe. That's what homomorphic encryption promises. For organizations bound by regulations requiring data to remain encrypted at all times, this technology could enable cloud computing on sensitive data that currently can't leave on-premises systems. While still computationally expensive and not widely deployed, homomorphic encryption would allow a cloud provider to run analytics, searches, and computations on your encrypted data, returning encrypted results that only you can decrypt. Symmetric encryption requires the same key for encryption and decryption. Asymmetric uses key pairs, and transport encryption protects data in motion. All require decryption for processing. Only homomorphic encryption enables computation on data while it remains encrypted. 36. An enterprise architect needs to design applications that assume no inherent trust between components. Which security model reflects this approach? A. Perimeter security. B. Zero trust security. C. Defense depth. D. Shared responsibility. Do you know the answer? Correct answer, B. Zero trust security. Explanation: option B is correct because the zero trust security model assumes no trust between any components, verifying every connection and request. Option A is incorrect because perimeter security trusts everything inside the network boundary, which is the opposite of assuming no inherent trust. Option C is incorrect because defense in depth uses multiple layers, but doesn't specifically assume zero trust between components. Option D is incorrect because shared responsibility defines security duties division, but doesn't address trust assumptions between components. Zero trust security fundamentally reimagines network security by eliminating the concept of inherent trust. Traditional security models assume everything inside your network perimeter is trustworthy, like assuming everyone inside your house is family. Zero trust flips this completely, assuming that every user, device, and connection could be compromised, requiring verification for every single interaction. In cloud architectures, this means every API call is authenticated, every network connection is verified, and every data access is logged and analyzed, regardless of where it originates. It's like requiring ID checks for every room in a building, even for people already inside. This paranoid approach is actually perfect for cloud environments where traditional perimeters don't exist. Perimeter security trusts internal traffic. Defense in depth adds layers without removing trust. And shared responsibility defines duties without addressing trust. Zero trust uniquely assumes no inherent trust anywhere in the system. 37. Which cloud service model requires customers to manage the most security controls, including OS hardening, patching, and application security? A. Software service. B. Platform service. C. Infrastructure service. D. Function service. Can you guess the answer? Correct answer, C. Infrastructure service. Explanation: option C is correct because infrastructure service requires customers to manage everything above the hypervisor, including OS and application security. Option A is incorrect because software service requires customers to manage only data and user access, with providers handling all other controls. Option B is incorrect because platform service customers manage applications and data, while providers handle OS and infrastructure security controls. Option D is incorrect because function as a service abstracts away most infrastructure, requiring minimal customer security management. Infrastructure as a service demands the most extensive security management from customers of any cloud service model. In IaaS, customers inherit massive security responsibilities, starting from the operating system layer all the way up through applications and data. You're responsible for OS hardening, disabling unnecessary services, configuring firewalls, managing ports. You handle all patching, OS updates, security fixes, driver updates. You manage application security, code reviews, vulnerability scanning, secure configurations. You control access management, encryption keys, network security groups, and monitoring. It's like being handed keys to an empty building and being responsible for installing and maintaining everything inside, including locks, alarms, and cameras. Software as a service handles most security for you. Platform as a service manages the OS and below. And function as a service abstracts most infrastructure. IaaS provides maximum control, but demands maximum security responsibility from customers. 38. Your organization needs content delivery acceleration for global users accessing static website assets. Which technology caches content at edge locations? A. Load balancer. B. CDN network. C. VPN tunnel. D. Database cluster. Do you know the answer? Correct answer, B. CDN network. Explanation: option B is correct because content delivery. Networks cache static content at edge locations globally for faster user access. Option A is incorrect because load balancers distribute traffic across servers but do not cache content at global edge locations. Option C is incorrect because VPN tunnels provide secure connections but do not cache or accelerate content delivery to users. Option D is incorrect because database clusters provide data redundancy and performance but do not cache static content at edges. Content delivery networks revolutionize global content distribution by bringing your data closer to users. When your organization needs to serve static website assets like images, videos, and JavaScript files to users worldwide, CDNs cache this content at edge locations, data centers strategically positioned near population centers globally. Instead of every user requesting content from your origin server potentially thousands of miles away, they receive it from an edge location, perhaps just miles away. This dramatically reduces latency, improves load times, and enhances user experience while reducing load on your origin servers. Think of it like having convenience stores in every neighborhood, instead of making everyone drive to a central warehouse. Load balancers distribute traffic, but don't cache globally. VPN tunnels provide secure connections without acceleration. And database clusters improve data availability, but don't cache static content. CDNs specifically solve the global content acceleration challenge. 39. A tax preparation company needs infrastructure that scales up 10x during tax season, then scales down. Which characteristic eliminates paying for idle resources year-round? A. Measured service. B. Rapid elasticity. C. Resource pooling. D. Network access. Can you guess the answer? Correct answer, B. Rapid elasticity. Explanation: option B is correct because rapid elasticity enables scaling infrastructure up 10x during tax season, then back down automatically. Option A is incorrect because measured service tracks usage for billing, but doesn't automatically scale resources based on seasonal demands. Option C is incorrect because resource pooling shares infrastructure among customers, but doesn't adjust individual customer capacity seasonally. Option D is incorrect because network access provides connectivity to services, but doesn't address seasonal capacity scaling requirements. Tax preparation companies face extreme seasonal scaling challenges that make rapid elasticity absolutely essential. During tax season, these companies experience 10x or higher traffic as millions of users rush to file before deadlines. Then traffic drops to nearly nothing for the rest of the year. Rapid elasticity allows infrastructure to expand like a balloon during tax season, automatically provisioning hundreds of additional servers to handle the load, then deflate back to minimal resources when the season ends. This eliminates the waste of maintaining peak capacity year-round. Imagine paying for a 500-room hotel, but only filling it 1 month per year. The infrastructure scales automatically based on actual demand, ensuring customers get responsive service during crunch time, while the company only pays for resources when they are actually needed. Measured service tracks the usage, resource pooling shares infrastructure, but only rapid elasticity provides the automatic scaling that eliminates year-round idle resources. 40. In Platform as a Service, which component is managed by the cloud provider, while customers focus on application development and deployment? A. Application code. B. Operating system. C. Business logic. D. User data. Do you know the answer? Correct answer, B. Operating system. Explanation: option B is correct because PaaS providers manage operating systems, middleware, and runtime environments, allowing customers to focus on application development and deployment. Option A is incorrect because application code is the responsibility of the customer in a PaaS environment. Option C is incorrect because business logic is part of the application and remains the responsibility of the customer. Option D is incorrect because user data and its management always remain the responsibility of the customer, regardless of the service model. Platform as a Service creates a clear division of responsibilities where providers handle the complex platform layers. In PaaS, the operating system sits firmly in the provider's domain. They install it, configure it, patch it, secure it, and optimize it for the platform's needs. This includes managing kernel updates, security patches, driver compatibility, and system-level configurations that would normally consume significant IT resources. Developers using PaaS never even see the operating system. They simply deploy their applications to the platform, and everything below just works. It's like renting a fully furnished apartment where building management handles all maintenance and utilities. You just move in and live. Application code remains the customer's responsibility because that's their unique business logic, as does business data. But the operating system, along with middleware and runtime environments, is completely abstracted away and managed by the PaaS provider. 41. Which cloud deployment model requires the highest capital investment but provides maximum control over security and compliance for sensitive operations? A. Public cloud. B. Private cloud. C. Community cloud. D. Hybrid cloud. Can you guess the answer? Correct answer, B. Private cloud. Explanation: option B is correct because private clouds require significant capital investment but provide complete control over security and compliance. Option A is incorrect because public clouds require no capital investment using a pay-as-you-go model with shared infrastructure control. Option C is incorrect because community clouds share costs among members, reducing individual capital requirements while sharing control. Option D is incorrect because hybrid clouds can reduce capital needs by combining private infrastructure with public cloud services. Private cloud deployment requires the highest capital investment, but delivers maximum control for sensitive operations. Building a private cloud means purchasing and maintaining your own servers, storage systems, networking equipment, and data center facilities, or dedicated hosted infrastructure. This significant capital expenditure can run into millions of dollars before you process a single workload. However, for organizations handling extremely sensitive data or operating under strict regulatory requirements, this investment buys complete control over every aspect of the infrastructure. You control physical access, network configurations, security implementations, and compliance measures without any multi-tenancy concerns. It's like buying your own office building versus renting. Massive upfront cost, but total control. Public clouds require zero capital, with pay-as-you-go pricing. Community clouds share capital costs among members, and hybrid clouds can reduce capital needs by leveraging public resources. Private cloud stands alone in requiring maximum capital for maximum control. 42. Your company wants to ensure cloud costs don't exceed budgets while tracking spending by project. Which cloud characteristic provides this financial visibility? A. Rapid elasticity. B. Measured service. C. Resource pooling. D. Self-service. Do you know the answer? Correct answer. B. Measured service. Explanation: option B is correct because measured service provides detailed usage tracking and cost allocation, enabling budget control by project. Option A is incorrect because rapid elasticity enables scaling but doesn't provide cost tracking or budget control mechanisms. Option C is incorrect because resource pooling optimizes infrastructure utilization but doesn't track costs or enforce budget limits. Option D is incorrect because self-service enables resource provisioning but doesn't provide cost visibility or budget enforcement. Measured service provides the financial transparency that transforms cloud computing into a controllable expense. Every action in the cloud generates metrics. Launching a VM creates compute hour charges, storing data generates gigabyte month costs, transferring data incurs bandwidth fees. Measured service captures all these metrics with precision, allocating costs down to individual resources, projects, and departments. This granular tracking enables organizations to set budget alerts that trigger before overspending occurs, generate detailed cost reports for chargeback to departments, and identify waste like forgotten test environments still running. It's like having an itemized phone bill that shows every call, text, and data usage, rather than just a total. This visibility enables true cost optimization and budget control. Rapid elasticity handles scaling. Resource pooling optimizes sharing, and self-service enables provisioning, but measured service specifically provides the financial visibility and control mechanisms organizations need. 43. An organization needs to meet RTO objectives of 1 hour with automatic failover across regions. Which cloud capability best supports this requirement? A. Geographic distribution. B. Vertical scaling. C. Horizontal scaling. D. Resource pooling. Can you guess the answer? Correct answer: A. Geographic distribution. Explanation: option A is correct because geographic distribution enables data replication and automatic failover across regions meeting aggressive RTO objectives. Option B is incorrect because vertical scaling increases single system capacity but doesn't provide regional failover for recovery objectives. Option C is incorrect because horizontal scaling adds more instances, but doesn't specifically address cross-region failover for disaster recovery. Option D is incorrect because resource pooling shares infrastructure efficiently, but doesn't provide geographic redundancy for RTO requirements. Geographic distribution is the cornerstone of meeting aggressive recovery time objectives in disaster recovery planning. When an organization needs to restore operations within 1 hour of a disaster, having data and applications distributed across multiple geographic regions becomes essential. Geographic distribution ensures that if one region experiences an earthquake, flood, or power grid failure, your applications can automatically fail over to another region hundreds or thousands of miles away. This isn't just about having backups, it's about having live, synchronized copies of your infrastructure ready to take over instantly. The automatic failover mechanisms detect failures and redirect traffic to healthy regions without human intervention, often achieving recovery in minutes rather than hours. Vertical scaling just makes individual systems bigger. Horizontal scaling adds more systems in the same location. And resource pooling shares infrastructure, but only geographic distribution provides the regional redundancy essential for aggressive RTOs. 44. Which type of encryption should customers control the keys for when storing sensitive data in public cloud environments for compliance? A. At-rest encryption. B. In-transit encryption. C. In-use encryption. D. Perimeter encryption. Do you know the answer? Correct answer, A. At-rest encryption. Explanation: option A is correct because customers should control encryption keys for data at rest in public clouds to meet compliance requirements. Option B is incorrect because in-transit encryption focuses on securing data as it moves between systems, and the keys are often managed as part of the connection protocol rather than by the customer. Option C is incorrect because in-use encryption is an emerging technology that protects data while it is being processed, but it is not yet widely available for customer key management. Option D is incorrect because perimeter encryption is not a standard encryption classification, and traditional perimeter security models are less applicable in cloud environments. When storing sensitive data in public clouds, controlling encryption keys for data at rest becomes a critical compliance requirement. Data at rest refers to information stored on disks, databases, file systems, object storage. Essentially any data not actively moving through networks. For compliance and security, organizations must maintain control over the encryption keys used to protect this stored data, ensuring that even cloud providers cannot access the plaintext information. This is typically achieved through customer-managed keys, where you generate, rotate, and control access to the encryption keys, while the cloud provider handles the encryption operations. It's like storing valuables in a bank vault but keeping the only key yourself. In-transit encryption protects moving data. In-use encryption is still emerging, and perimeter encryption isn't a standard classification. At-rest encryption with customer-controlled keys specifically addresses compliance requirements for stored sensitive data. 45. A development team needs to quickly provision test environments without waiting for IT approval. Which cloud characteristic enables this autonomous resource management? A. On-demand self-service. B. Broad network access. C. Resource pooling. D. Measured service. Can you guess the answer? Correct answer, A. On-demand self-service. Explanation: option A is correct, because on-demand self-service allows users to provision resources immediately without human intervention or approvals. Option B is incorrect because broad network access provides connectivity from various locations, but doesn't enable autonomous resource provisioning. Option C is incorrect because resource pooling optimizes infrastructure sharing, but doesn't eliminate the need for provisioning approvals. Option D is incorrect because measured service tracks usage for billing, but doesn't enable self-service provisioning without approvals. On-demand self-service empowers development teams with autonomous resource management, eliminating IT bottlenecks. This cloud characteristic means developers can provision compute instances, storage volumes, databases, and other resources immediately through web portals or APIs without filing tickets, waiting for approvals, or scheduling meetings with IT. It's like having a vending machine for IT resources. Insert your credentials, select what you need, and receive it instantly. This autonomy accelerates development cycles dramatically, as teams can spin up test environments in minutes rather than waiting days or weeks for IT provisioning. The self-service portals enforce policies and quotas automatically, ensuring governance without human gatekeepers. Broad network access provides connectivity, resource pooling optimizes infrastructure, and measured service tracks usage. But on-demand self-service specifically eliminates the human approval bottleneck that slows traditional IT provisioning. 46. Your organization must demonstrate compliance through independent verification of cloud security controls. Which role provides this third-party validation service? A. Cloud provider. B. Cloud broker. C. Cloud auditor. D. Cloud carrier. Do you know the answer? Correct answer, C. Cloud auditor. Explanation. Option C is correct because cloud auditors provide independent third-party assessments and validation of security controls for compliance demonstration. Option A is incorrect because cloud providers implement controls but cannot provide independent validation of their own security measures. Option B is incorrect because cloud brokers facilitate service selection and integration but don't provide independent compliance validation. Option D is incorrect because cloud carriers provide network connectivity but don't assess or validate security control implementations. Cloud auditors provide the independent validation that transforms security claims into verified compliance. Organizations can't simply declare their cloud environments are secure and compliant. Regulators, customers, and partners demand proof from an unbiased third party. Cloud auditors conduct systematic examinations of security controls against frameworks like SOC 2, ISO 27001, PCI DSS, and HIPAA, producing attestation reports that carry legal weight. These auditors have no financial stake in the outcome, ensuring their assessments are objective and trustworthy. They examine everything from access logs to encryption implementations, interview staff, review procedures, and test controls to verify they work as claimed. Cloud providers implement controls but can't independently validate their own work. Brokers facilitate services without assessing security, and carriers provide connectivity without compliance validation. Only cloud auditors possess the independence and expertise for third-party compliance validation. 47. Which storage type provides shared file systems accessible by multiple systems simultaneously, similar to traditional network-attached storage in cloud? A. Object storage. B. Block storage. C. File storage. D. Archive storage. Can you guess the answer? Correct answer, C. File storage. Explanation. Option C is correct because file storage provides hierarchical file systems with concurrent access, similar to traditional NIST solutions. Option A is incorrect because object storage uses flat namespace with URL access, not providing traditional file system hierarchies. Option B is incorrect because block storage attaches to individual VMs as raw volumes, not providing shared file system access. Option D is incorrect because archive storage optimizes for long-term retention of rarely accessed data, not concurrent file access. File storage in the cloud replicates traditional network-attached storage functionality for shared access scenarios when multiple systems need to access the same files simultaneously, like a shared documents folder or application configuration files. File storage provides hierarchical file systems with familiar folder structures and concurrent access protocols. It's essentially NIST in the cloud, supporting standard protocols like NFS and SMB that applications already understand. Multiple compute instances can mount the same file system, reading and writing files in a coordinated manner with file locking and permissions. This makes it perfect for content management systems, shared home directories, and legacy applications expecting traditional file system semantics. Object storage uses flat namespaces with URLs. Block storage attaches to single VMs as raw volumes, and archive storage optimizes for cold data. File storage specifically provides the shared hierarchical file system access that many applications require. 48. A company wants to gradually migrate from on-premises to cloud while maintaining some legacy systems indefinitely. Which deployment model supports this transition strategy? A. Public cloud. B. Private cloud. C. Community cloud. D. Hybrid cloud. Do you know the answer? Correct answer, D. Hybrid cloud. Explanation: option D is correct because hybrid cloud enables gradual migration while maintaining on-premises legacy systems connected to cloud resources. Option A is incorrect because public cloud alone doesn't maintain on-premises systems or support gradual migration with legacy integration. Option B is incorrect because private cloud focuses on dedicated resources but doesn't inherently combine on-premises with public cloud. Option C is incorrect because community cloud serves shared organizations but doesn't specifically support on-premises to cloud transitions. Hybrid cloud deployment provides the perfect migration path for organizations with legacy system constraints. Many companies can't simply abandon their on-premises infrastructure overnight. They have legacy applications that can't move to cloud, regulatory requirements keeping certain data on premises, or massive investments in existing systems. Hybrid cloud enables a gradual, controlled migration where you move appropriate workloads to the cloud, while maintaining critical systems on premises, all connected as one unified environment. This approach lets organizations modernize incrementally, learning cloud operations with less critical systems before moving core applications. The on-premises and cloud components communicate seamlessly, allowing data and applications to flow between environments as needed. Public cloud alone abandons on-premises systems. Private cloud doesn't leverage public cloud benefits, and community cloud serves shared organizations without addressing migration. Hybrid cloud uniquely supports this gradual transition strategy while maintaining legacy systems indefinitely. 49. In cloud computing, which technology abstraction allows multiple customers to unknowingly share the same physical servers while maintaining complete isolation? A. Containerization layer. B. Virtualization layer. C. Application layer. D. Network layer. Can you guess the answer? Correct answer, B. Virtualization layer. Explanation: option B is correct because virtualization creates isolated virtual machines on shared physical hardware, enabling secure multi-tenancy. Option A is incorrect because containerization shares operating system kernels between containers, not providing complete isolation for multi-tenancy. Option C is incorrect because the application layer operates within virtual machines or containers, not creating the isolation mechanism itself. Option D is incorrect because the network layer provides connectivity but doesn't create isolated computing environments on shared hardware. The virtualization layer is the technological foundation that enables secure multi-tenancy in cloud computing. Through virtualization, multiple customers can unknowingly share the same physical servers while maintaining complete isolation from each other. It's like having soundproof apartments in the same building where neighbors can't hear or access each other's spaces. The virtualization layer, primarily the hypervisor, creates these isolated virtual machines, each believing it has dedicated hardware while actually sharing physical resources. This isolation is so complete that even if one VM is completely compromised, it cannot access memory, storage, or network traffic of other VMs on the same host. Containerization shares kernel resources between containers, reducing isolation. The application layer operates within VMs, not creating them, and the network layer provides connectivity without compute isolation. Only the virtualization layer provides the complete isolation necessary for secure multi-tenant cloud environments. 50. An enterprise requires predictable monthly costs while maintaining ability to burst capacity during campaigns. Which pricing combination best meets these requirements? A. Only on demand. B. Only reserved. C. Reserved plus on demand. D. Only spot. Do you know the answer? Correct answer, C. Reserved plus on demand. Explanation. Option C is correct because combining reserved instances for baseline with on-demand for bursts provides predictable costs plus flexibility. Option A is incorrect because only on-demand pricing varies monthly based on usage, not providing the required cost predictability. Option B is incorrect because only reserved instances can't handle burst capacity beyond the reserved amount during campaigns. Option D is incorrect because spot instances have variable pricing and availability, not providing predictable costs or guaranteed capacity. Combining reserved instances with on-demand capacity creates the optimal pricing strategy for enterprises with baseline and burst requirements. Reserved instances provide significant discounts, often 50 to 70% off on-demand prices, in exchange for committing to a certain capacity level for 1 or 3 years, giving you predictable monthly costs for your baseline workload. This covers your always-on production systems that run 24/7. Then when marketing campaigns or seasonal events drive traffic spikes, on-demand instances automatically handle the burst capacity without any commitment, scaling up and down as needed. It's like having a monthly transit pass for your daily commute, while using pay per ride for occasional extra trips. Pure on-demand lacks cost predictability, pure reserved can't handle bursts beyond committed capacity, and spot instances have availability risks. The reserved plus on-demand combination delivers both predictable baseline costs and flexible burst capacity. You have reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.